Is there a number that we can divide out of the first problem? No. So we're going to set up our x. What goes in the top of the x? Negative 15. And in the bottom? Because 4 times negative 25. Good. So what are factors of negative 20? Negative 100, that's negative 15.
Negative 20 and 5.
Sometimes you say the answer on accident. So n minus 20, n plus 5. Have I finished this problem?
No.
20 is divisible.
I have to divide by 4. You always have to divide by whatever number is in front of the squared term. Especially if you did slide, which is a times c, 4 times negative 25. You're going to have to divide in bottoms up every single time. Yes, dear. That's totally fine. Same thing. All right, so we're going to divide by 4. 20 divided by 4 is 5. And then 4 doesn't go into 5, so 4n plus 5. Final answer. You don't have an equal sign, so no equals. That's the answer. Cis factor. Also, there's no equal sign, so if you poof an equal sign out of nowhere,
It's wrong.
what are you doing with your life? You even asked me, too. Next one. Can you divide anything out? No. So what goes in the top of the x? And 16 on the bottom. What?
Negative 1, negative 16.
So we have n minus 16, n minus 1. Divide by 4. That's my a term. So we're going to have n minus 4. 4n minus 1. How many of you got all of those correct? Good. Well, setting them equal to 0. All right. Take out a red pen. You're going to grade the homework. AB is number 1. Identify the given arc as a major arc, minor arc, or semicircle. Then find the measure of the arc. AB is already 2 letters, so what kind of arc do I already know it is? It's definitely minor. Minor arcs are always written with 2 letters. So AB, it looks like off first hand that we don't know what the measure of AB is. But we do. Here's why. Y'all need to learn to read under pictures. What does an upside down T mean?
Perpendicular.
Perpendicular. What does perpendicular mean?
90.
90 is not a full sentence.
90-degree angle.
That's still not a full sentence.
Equals to 90.
Nope.
Perpendicular is when 2 lines cross and make a 90-degree angle.
Thank you. Y'all need to, listen, you need to learn how to form full sentences. What is perpendicular? 90 degrees? No. 90 degrees is 90 degrees. Adjacent? No. They are adjacent. But it's when no, not even adjacent. When 2 lines come together, they form 90 degrees. So that means that where AC and BE, or EB, come together, they form 90. So this is 90, and this angle is also 90. So the arc AB is going to be congruent to its central angle. The central angle, now looks like a baseball field, is 90 degrees. So what is the measure of its arc?
90.
90.
90.
Would you
just put 90, or is there like
just 90 degrees.
we put degrees still?
Yep, it's still degrees. Number 2, A, B, C. So starting at letter A, we're going to go left around the circle or right around the circle?
Right.
Right around the circle. So here's what I want you to notice. A and C are both a part of a very particular line in the circle. What kind of line is that?
Diameter.
The diameter. An arc that starts and ends on the diameter is called a semicircle. So what is the full measure of ABC? Arc. 180, and I just said it makes it a semicircle. All right, oops. Next one, what letters do we have here?
A, B, D.
A, B, D. All right, let me put back what I've already erased. So A, B, D. So we're starting at letter A. In which direction are we going?
Right.
To the right, all the way around. Sorry, I ran out of room. all the way to D. So we have 90 degrees. BC, what is that chunk? 90. So we have 90 and 90. The central angle of DC is 40, so that means the arc of DC is also 40. So add all three of them up. What do we get? 220. Which makes it what kind? Major arc. BC is 2 letters, so it's already a minor arc. So from B, you need, if it's a minor arc, you need to go directly to C, the closest direction. So we're going to left around the circle or right around the circle? Right. So how many degrees is that? 90. All right, what is the next? BAC. Oops. Start at B, go towards A, end at C. So to the left, yes. So if you look at this, how many degrees fit inside of a full
360.
circle? 360. All right, you'll have all of the circle except for 90 degrees of it. So what do you do there? Subtract from 360. So you get 270, which makes it what kind of arc? Major. Remember that if the arc is over 180, it is already a major arc. DAB, start at D. Which direction we go, left or right?
Left.
To the left. End at B. So here's what you would need to find out. You need to find what DA is. You don't have to yell at the answer, just pause. Find DA. So what I would notice is DA and DC start and end on the diameter. Does everyone see the diameter? So start and end on the diameter. So how many degrees would that be? The full from A to C is 180. So if that full side is 180, how many degrees do I already have? 40 by DC. So that means what's left for DA would be 140. 140. So that would be a major. Questions on that one? We all okay? Okay. AD. So that is a minor arc already. Minor. So starting at A, do we go left or right?
Left.
Left, because you want the closest route to the letter D. So we get 140. And then last CD, minor, which is 40. Awesome. So this is a portion of what we learned yesterday. Pretty much, I want to say all of it, but maybe we learned a little bit more. The other portion that we're going to do today from yesterday is number 10 and 11, still in your student journal. Number 10, it says in circle K, find the measure of DE. So DE is circle K. Do you see a diameter in this picture? I see 2 of them. One of them will help you. Which diameter will help you? DA. CE would not help you because there's no information about CD at all. But we know AE, the arc here, will be how many degrees? 55. And you know all the way to D would be, they have to add up to 180. So what would I do there? Subtract. So 125 is the correct answer. All right, number 11, find the value of x. If you notice on this circle, every piece is accounted for. You have 40, 70, 75 plus 2x and 5x. What do you know about all of the arcs in the circle? They add up to 360. So what can I do with those?
You can add them all. Set them equal to 360.
Add up, set them equal to 360. Start with 40 plus 70, just going around clockwise, plus 75 plus 2x plus 5x. They will all equal 360. It just ran out of room. Equals 360. 40, 70, and 75 make 185. 2x and 5x make 7x. Subtract 185. very passive-aggressive. So x equals 25. So it said find the value of x, but was that the end of what they asked us to do? What else? Find the measure of AB. So AB is right here, so what am I going to do with 25? Yeah. Multiply it by 5. If I have 5 quarters, I have 120, well, $1.25, but and here's 125.
With quarters.
Yep. All right, so here's what we're going to do. We're going to go into 10.3. We are on a faster pace because now we have 9 minutes left in class. So, I didn't finish doing that. So, here's what I want you to write, actually. A chord, in review, a chord starts and ends on the circle. Okay? A chord starts and ends on the circle. So, what I want you to write is that a chord will never equal an arc. Chord will never equal an arc. Anywhere you want. Anywhere you're going to see it, and remember, a chord will never equal an arc. The reason a chord will never equal an arc is an arc's answer will always be in degrees. So whenever you see an arc, you want to write this down too. Arc will always be an answer in degrees. So 50 degrees, 20 degrees, 6 degrees, 180 degrees, 220 degrees, whatever. Whereas a chord, it's a segment. So it will always be in length. So we're talking inches, yards, meters, miles, etc. So they will never equal each other. Okay, you're going to learn something about them. They do have a somewhat relationship between the two. But you have to use the relationship properly. Alright, so the first thing we're going to talk about, it's called a congruent corresponding chords theorem. Alright, so if you have two congruent chords in a circle, then their arcs are also going to be congruent. So let's give these letters A, B, C, D. So in my picture, you can just draw it. Draw a circle with the two lines. And let's say that AD was congruent to BC. They're not perfect because I just winged it, but just pretend that they are. All right, and let's say that BC was equal to 5. Let's also say that arc BC was equal to 100. Okay? Chords will never be equal to arcs. Arcs will be congruent to arcs, and chords will be congruent to chords. So here's what would happen. If BC equaled 5, AD would also equal 5. So that means this is 5 and this is 5. If the measure of BC, so the arc, which is right here, sorry, I'm trying to highlight it. Maybe I'll do pink. So if BC was 100 degrees, that means the measure of arc AD would also be 100 degrees. All right, so just keep in mind throughout this entire section, chords are congruent to chords. Arcs, which is like the crust of a pizza, are congruent to arcs. All right, so using this theorem, we're going to do a problem. This is from your textbook. You don't have to go there. Just look at it and think through it with me. Okay? In the diagram, circle P is congruent to circle Q. FG, which is right here, is congruent to JK, which is right here. So their chords are congruent. These are lines right there. FG and JK. It says the measure of arc, JK, is 80 degrees. So what is the measure of arc, FG? It's also going to be 80 degrees because of the theorem that we just talked about. Okay? That doesn't mean that the chords are 80 because a line cannot be degrees. All right? The second thing, I want you to write this down pretty quickly. If a diameter and a chord form 90 degrees, if a diameter and a chord form 90 degrees, if a diameter and a chord form 90 degrees, then the chord is bisected. If a diameter and a chord form 90 degrees, then the chord is bisected. What does bisected mean? Cut in half. All right, that's what this theorem says. So, in this picture, we have a circle. What is my diameter? Because clearly we just talked about diameters. My diameter is not HK. JL is my diameter, which makes HK my chord. Diameters have to go through the center. They connect and they form 90 degrees. That means that the chord, which is HK, is cut directly in half. So if NK is 7, what is HN? 7. So it asks me to find HK. There is no line above it. This means find the length of the line HK. So what is the measure of HK? 14, because 7 and 7 make 14. All right, the second portion, find the measure of arc, HK. All right, so it also, since their chords are congruent, that means their arcs are also going to be congruent. So that means 11x is going to equal 70 plus x. So you will set them equal. So subtract x. So x equals 7. Did it ask me what x was? No, it asked me to find HK, which is the whole, is the whole arc. So 11 times 7 is 77. 70 plus 7 is 77. So we have 77 plus 77, so we get 154. All right. So those are the two properties. We're going to do one more together. It's in your student journal. Turn quickly. Page 290, I think.
No.
292 then. All right, so it asks to find the measure of WX. A lot of people would say 3.6, and they would be wrong. 3.6 is the measure of a chord. You need to find the measure of the central angle, which would be this angle right here. To figure that out, you can always take the endpoints of your arc and draw towards the center. What would the measure of this angle be? Why 42? Nope, they're called something. They're congruent. Why are they congruent?
Because
they're vertical angles. Yep. Vertical angles. So 42 is the first answer. YZ. YZ is a line segment. All right, just use your common sense here. All right. Yeah, if their angles and their arcs were congruent, that means that line between them is also congruent. So that's going to be 3.6. What about WZ? 9.2. All right, and then the last. All right, so if WX was 42, you got to wait. The diameter is WY. We're trying to find XY. So we're trying to find this angle right here. Alright, so look. If two angles start and end on the diameter, that makes a semicircle. How many degrees is a semicircle? 180. So how do you find that missing piece? Subtract from 180. So 180 minus 42. So 138 was the answer.